How many of you work in cybersecurity? All right, you are working in the most important field in technology today. So why do I say that? I've been in the technology industry for more than 2 decades. And when you look at the history of technology, it used to be that technology was cordoned off into a small segment of the world, right? Maybe you used software to do something very specific. Maybe you had a control system that had hardware with software behind it. Now technology is pervasive. Technology is in your pocket. Technology is what we're doing right here. Technology is how you book your flights. It's how medical research gets done. It's how manufacturing gets done. And so I would argue that the most important thing in technology right now is security. And the reason is that it's an unsolved problem with an ever-growing attack surface. And so one of the ways that I think we can fix this is by reimagining the way that security tools are done. My name is Joshua Burgeon. I am the Chief Product Officer at Upwind Security, which is a cybersecurity startup. And I'm here to talk to you about how bridging runtime and build time intelligence will help reduce friction between your DevSec and Ops teams and help improve your security posture so that you can solve problems faster with reduced noise and less time to root cause. So I'm going to mix talking about how you would do this in general and then spend some time showing you how Upwind, how my startup, does this in specific. So first I'm going to step back a little bit and give you a brief history of cloud security. I'm not going to start at the beginning of time. But in terms of cloud security, in 2015, Gartner made a prediction that 95% of cloud securities will be the customer's fault. And this is a big shift from the way that traditional infrastructure thought of of security. I am old enough to remember when infrastructure was all on-prem and things were hidden behind a procurement process and they took 3 to 6 months to get installed and they were kind of rigidly managed and you had maybe a firewall in front of you. Defense in depth hadn't even really come to the forefront. A few years later, what you started seeing was the emergence of workload protection and detection and response tools, and then compliance, and we'll talk a little bit more about this later, became a major focus for security. As people started adopting the cloud, what you started seeing was tool proliferation, and this happens everywhere. Nobody had figured out, how do we combine these things into one single platform? So people started buying tools for API security, for posture management, for vulnerabilities and code scanning, for threat detection and response. Obviously, this solves one problem, which is that you had security holes, but it creates another one. By 2023, statistics showed that 45% of breaches in the technology industry overall were cloud-based. There's this old, probably apocryphal story of Billy the Kid, and when they captured him in the early 1900s, he was a bank robber. They said, "Billy, why do you rob banks?" What did he say? Because that's where the money is. So why are the attackers going to the cloud? Because that's where increasingly everybody is moving, and it's an increasingly complex world that's not fully secured, and it gives them the ability, through all of these different attack surfaces, to install ransomware, to exfiltrate data, to inject data into your platform. So this number is only going to increase as more and more people adopt the cloud. You're at a conference for AWS, actually where I previously worked for 8 years. And what do they say? They say something like 75 to 80% of workloads are still on-prem. And at the same time, AWS is a $100 billion a year run rate business. And then if you look at the other cloud providers, hard to believe, but there are some, those people are growing at a similar kind of double-digit percentage year over year. So that means all these workloads are moving to the cloud. Everybody's adopting cloud-native application development workflow, and with that brings all of these breach opportunities. So when we look ahead, we're in the year 2024. When we look to 2025 and 2026, Gartner and other analysts have suggested that people are going to move away from unfettered access to the cloud with no security. That makes sense. They're going to move away from having 10 or 15 different cloud-native security tools and move towards something they call the CNAPP, a cloud-native application protection platform. Upwind happens to be one of them. There are others. And they said that by 2026, that's not that long from now, 80% of enterprises will consolidate their tooling to 3 or fewer vendors. And there is an actual reason for this, and it's not just the success of the vendor sales teams. You can kind of think about this. Technology comes in waves. It often repeats itself. You have an innovation, everybody fans out and does things differently while it's not clear that there's one right way to do something, and then people consolidate. You're seeing that in the cloud right now. You're going to see that in security. So why is that going to happen? So what are the unique challenges of operating in the cloud? I divide these into 3 categories. The first is that it's a much more complex environment. I mentioned earlier that I come from the days when I started out, people were racking and stacking servers. And although that brought some complexity with it, you could tightly control the types of servers that got into your environment, the types of operating systems that were used, and developers and ops people had very little ability to spin things up and down without super tight controls. In fact, the tightest control was the procurement process. It would take 3 months or 6 months to get something approved and ordered and delivered and installed and then configured. That's not the case anymore. And people have moved from a world where they just had bare metal servers and a world where they just had VMs, virtual machines, to a world where they have virtual machines. Maybe one or more container orchestration models, right? Maybe they're using ECS and EKS, or maybe they're using ECS and Fargate and EKS, and maybe they're using Rancher on-prem for their endpoints. And one where you wanted to give developers the freedom to innovate, and with the freedom to innovate comes that complexity in the environment. Maybe you're also using a lot of the 250 or 300 AWS managed services. That complexity increases the security attack surface, which requires you secure these things in a more complex and kind of detailed manner. What that leads to is more complex risk. Before, the main risk that people thought about was someone's going to penetrate my external defenses, right? My firewall or the ports that I had closed, and they're going to get access to my network. That kind of perimeter protection, in my opinion, was actually a false sense of security. So you had this like hard outer shell and then this soft interior. So once someone got inside your network, they had pretty much access to anything. And people spent all their time fortifying their external defenses. And then once people got on-premise, they could do whatever they want. If you actually look at the biggest breaches in security right now, so has everyone watched the Ticketmaster breach that was just announced? Something like 500 million users' information was leaked. They're obviously not giving all the information out, but I can tell you what happened, which is that not because I'm inside Ticketmaster, I've just seen these things before. What happened is they focused on perimeter protection, and they didn't focus on all of the other complex risks that are hard to manage, right? Identity, posture, configuration, APIs, code vulnerabilities, all of the kinds, and the ways that those combine. And by not doing that, because it's hard, because the tooling that's out there doesn't solve for that, you leave yourself wide open. So there's actually many other talks here, and talks that AWS has actually given in the past. If you ever look for one from either Claire Liguori or Eric Brandwein, who both work for AWS, I highly recommend it. They gave a talk a few years back about defense in depth, and that's what this is an attempt to solve for. But I would actually argue that the reason people aren't solving this is that the tooling doesn't make it easy. It doesn't correlate between all of these different areas of risk. And then the other thing that happened is in this cloud-native world, you no longer have security being solely the responsibility of the security engineering team or the security operations team. Now you have developers responsible for some aspects of security, usually securing their code. You have the DevOps people responsible for another area of security, usually securing the infrastructure that's kind of spinning up and down, especially in a Kubernetes or containerized world. And then you still have the security engineering and security operations team responsible for the firewalls or managing threats when they happen. And none of these people are talking to each other, and none of them are talking to each other because none of the tooling makes it easy for them to do so. So what happens is, and I can tell you this also from experience, even at AWS, as great as they are, when something happens, you spend an inordinate amount of time getting a bunch of smart people on a phone call or a Zoom call and saying, What happened? What is the history of events? How did we get here? What are we noticing? How can we reconstruct the logs? Who pushed the code to production? What does that code do? What do these identities do? And so when that happens, that of course means that you spend a lot more time figuring out how do we actually fix this problem, and you're left open for a longer period of time. So how do you fix this? Right? Gartner talked about CNAPPs. I'm talking about comprehensive cloud security. Whatever term you use, you need to solve this problem in 3 kind of simple but deceivingly easy steps. So the first is you need something, or some set of things, that discover every layer in your cloud infrastructure. You can't have something that only looks at your VMs, or only looks at your containers, or only looks at the network, or only looks at your CloudTrail logs, for example. If you are multi-cloud or hybrid cloud or something to that effect, you need something that looks across the clouds, across your containers, across your VMs. You need something that looks at both the data from the provider, from the managed services that you're using, and what's actually happening in your running environment, right, down to the process level, down to the packet level. Now, you don't necessarily need to build like a giant data warehouse and then Elasticache or Snowflake database, but you do need to have all of this information because it's important later to kind of do your investigations and your prioritizations. So the second thing you need to do is pull all of these risks and threats, no matter what they come from, posture, identity, vulnerabilities, APIs, you need to pull them together. But that is not enough. A lot of the early tools just did that. They pulled them all together, they showed everything to you, and then you struggled to prioritize things. For example, most traditional source code analysis tools, they will show you have 1,000 vulnerabilities in your code base, and then your developers will just give up in despair, not knowing which one of those they need to fix. Some of those are actually just theoretical. So you need to bring them all together, and then you need to prioritize them based on what's actually going on in the different layers inside your cloud infrastructure, based on what's happening in your network, based on the exposure, based on what someone could do with an identity or with access. And then the third thing you need is what I would call proactive end-to-end security, right? So you have everything that's in your cloud infrastructure. You have all of your risks and threats brought together and prioritized in one place. Then what you need to do is have a practice or a suite of tools that go along with a practice where you are monitoring things in real time and where most of your responses are either automated or as close to automated as they could be with minimal human intervention. You need to shift left and shift right at the same time. At Upwind, we happen to provide all of these things. I would love to believe we are the only cloud security platform out there, and maybe if you come to our booth, that is what I will tell you. But in reality, you could kind of try and put this together yourself, right? I mean, if you walked out of this session right now and said, I've learned at least something, it would be that these 3 practices are the basis for having a secure, modern cloud infrastructure. So what you need, in my argument, is that you need a runtime-powered cloud security platform. It is not possible to do those 3 things without deep insight into your runtime environment. By that I mean your running production environment, or your staging environments and your production environment. So what that means is that you have something that discovers everything and then kind of combines all of it together. So you're doing your cloud security posture management, which is vulnerability management, posture management identities. You're doing your workload protection in one place, right? Container security, serverless security, and then also your application security. All of these things intersect. In my opinion, if you have either purchased a tool or you have a practice where you've built something that is only covering one or a few aspects of this, or is covering them separately and not correlating the risks and the threats across this, you are not going to actually be secure in the cloud. So that is my kind of general commentary on cloud security. Now I want to spend a few minutes walking through how we at Upwind built a solution that addresses all of these areas. So again, it's about being secure during build time, securing your cloud overall, and secure at runtime. All of these things kind of go together. So again, I mentioned runtime. What I mean here, and I mentioned build time, you'll hear these terms a lot, shift left and shift right. What do people mean by those? By shift left, they typically mean the left-hand side of this graph here, which is really your development environment, your build practices, what your developers are doing, what your QA people are doing. The theory behind shift left tools, things that only do shift left, and this is a good one. It's a good idea. It's a good principle. If you fix all of the problems before they get to production, you will have no problems. Right? But the old joke is, the difference between theory and practice is that in theory, there is no difference. But in reality, this doesn't work. There's a couple of reasons. One is that there's this complete overload of information between all of the things that you will discover in this kind of development environment. And the second is that not all of the risks are obvious in development, right? Some of them don't become obvious until they get to production. The third reason you can't solve all these is it's very difficult to correlate across like identities and posture, your code base, and then other things that are like going on inside your network or between the way that things communicate. So shift left is an important part of securing the cloud, but by itself doesn't solve your problem. And then you often hear the term shift right. What does this mean? So shift right is you have a set of tools and practices that are focused on what's going on in my running environment. So you have things like firewalls. These are good to have. You have ACLs. You have other kinds of rules that prevent people from getting any access. And then when there is something that you detect that is going wrong or anomalous, you alert people. This is also a good practice, right? You should be knowing what's happening in your environment in real time, not 24 hours later based on some scan that only happens once a day, not based on what I would call a good intention of having somebody on your team periodically look through logs or monitor a Slack room, but something that alerts you to behavior that you need to dig into. Now, the problem with only shifting right is that, of course, number one, bad things have happened, and it would be nice to prevent the bad thing. We just talked about that. The other problem is that if you only have, say, threat detection and response tools, you get these security engineers with no context of how applications are supposed to run or how they're built. You also have no context with how did this happen? Was this caused by a recent deployment, right? Was this caused by a recent change to privileges that someone inadvertently gave access? Or is this something that the threat has been kind of lying in wait for 3 months, 6 months, and a year, and it really has nothing to do with the code base? You need that information because, of course, seconds count and minutes count when you're actually responding to threats. So we at Upwind believe that you have to shift left and shift right. You need aspects of your cloud security platform that are focused on preventing things from getting to production, but they're going to do that by combining your runtime context, what we know things are supposed to look like, the baseline in production, with what your developers are doing. And then similarly, when you are responding to threats in real time, you need to marry that with context from what happened from your developers. Was this a recent change in posture and identities? Is this something that's necessary for the functioning of the application, or was this just an error? So we would argue that if you do those two things together, as you see here on the bottom of the graph, you will reduce the noise that your developers and your ops people have to deal with by up to 95%. And I will actually show you in the platform what I mean by 95%. And you will reach root cause 10 times faster. So hopefully those sound like good things to you. Ultimately, I don't think most of you want to actually use a cloud security platform. I know that sounds provocative. But most of you actually want to be secure, right? You want your cloud environment to be secure. If you are CISOs or executives, you want to know that your cloud environment is secure, or whether it's getting more secure or less secure over time. The cloud security platform is only a means to that end. So a lot, in our experience, of security tooling is focused on that first piece, which is let me show you everything that's going on in your environment, or let me show you everything that's going wrong. They're not actually focused on the outcome that customers want. So that's what we set about to build. So inside of Upwind, we've kind of divided our value into 7 different parts. So the first is, and I will actually show you a live demo of the platform after this, recorded demo. So the first is that reducing noise by 95%. So what do I mean by that? This is one example. There are a lot of static code analysis tools. These are tools that look at the code base, and they tell you how many vulnerabilities, commonly called CVEs, that you have in your code base. Now, ideally, again, back to that theory and practice thing, ideally, you would fix 100% of those vulnerabilities. But there's two reasons this is impractical. First off, the vulnerabilities grow at a rate faster than your developers can fix them. Secondly, it's actually a waste of time. A lot of these vulnerabilities are either theoretical, meaning there's no exploit that's available right now. They are low severity, meaning even if somebody exploited the vulnerability, there's very little they can do on your machine. This is just things that security researchers find. Or, and this is something that I think Upwind excels at, although they're exploitable, if they're deployed on a machine that's in a sandbox, the ability to exploit that is very limited. So what we do is we funnel that down by taking that runtime context of like, how is this application actually deployed? Which of these vulnerabilities are actually on a machine that has access to the internet? And then how do I marry that with the severity of the vulnerability and whether it's exploitable and fixable? So this is a real example from a customer environment where they had 812 vulnerabilities that were found in kind of deployed applications, deployed images. But of that, only 799 packages were even in use. A lot of the packages are just in the base image or the open source package that you kind of pulled in together. And again, ideally, you would tighten down all of your images so it has no code that people aren't using. But the dependency graph is just too hard to manage. But then you can cut that down further and say there's only 61 of those packages, those vulnerable packages that are even on a machine that has any active internet traffic. Everything else is in a staging environment. And then you keep cutting it down further by marrying it with information like the exploitability, the fixability, and the CVSS, the vulnerability score. If it has all of those things together, that's something the developer should look at right now. And I will show you later how we give developers not just this context, but actually the information like what package to fix. Then the second thing that we do at Upwind is provide you this kind of unparalleled visibility into all those layers of your cloud infrastructure. So what this means is that we discover all of your VMs, all of your containers. So that's, again, whether you're using ECS, EKS, on-prem, vanilla Docker, we can support all of that. And we know how these resources communicate with the internet, with each other, with AWS services. That even lets us discover things like, hey, I've got a resource still communicating with the old version, the obsolete version of the instance metadata store. If any of you are familiar with that, that is a huge no-no. Don't do that. There have been a number of breaches, which is why AWS released V2 of IMDS. So we pull this all together into a map, which by itself can actually help you understand, I've got a complex cloud estate. What is going on? What are people deploying? Remember what I talked about with the complex risk and the complex infrastructure, right, where people can spin things up and down? You might not even know, even if you have good controls, what people are putting into your environment and how it communicates with managed services, with the internet, across cloud, etc. The next thing is API security. Traditional API security approaches work by using an API catalog that is created by your developers, managed maybe inside GitHub, and always out of date. It's never accurate. We just skip this approach. It's not worthwhile. We actually discover all of your endpoints in your production environment. We map all of the traffic that's coming into and going out of them so that we can tell you what is a normal request load, what's a normal amount of errors, what kind of information does this API normally process, which, as you can imagine, later lets you know what would be abnormal for this API to do. Like maybe there's an abnormally high volume in the API by itself, or maybe someone is using one of what are called CWEs, which are common weaknesses in APIs, and we run hundreds of tests for this. Maybe somebody is trying to inject data kind of into your APIs, which can be the precursor to them doing something on one of your resources that you really don't like. So again, that's the value of having that production runtime information, and then marrying it with, what did you actually deploy, right? This API is deployed on this resource, but where did it come from? Like what image is it on? What package did you deploy? I've mentioned baselines a few times. This is an incredibly powerful tool for any security platform, and it's why we baked it into Upwind. So we establish within 24 hours, or in the worst case, a week, automatically a baseline of your network traffic, your processes, what is normal access to files and databases, which again, we use to tell you whether or not something is happening anomalously. So that can be as simple as this machine has never communicated with the internet before and is suddenly doing so. Now, maybe that's innocuous, maybe you made a change, but a lot of times, again, that's the precursor of somebody reaching out and trying to install a package maliciously, which would then allow them to maybe commit kind of lateral movement onto one of your other resources. The same thing is true with, there's a lot of attacks that go through files. So that can be accessing your files, that's really obvious. Other things that are kind of tricky, but you can spot if you have runtime access to people's production environments, are things where someone is creating a file, or even these days there are fileless, in-memory file-based attacks. I mean, these are like, attackers are kind of always using novel ways to get into your environment. You can only detect that in runtime and real time. We also have the ability, of course, to scan your environment periodically. That can be super useful for non-containerized environments, VMs that you're not managing using infrastructure as code, like Terraform, CloudFormation. If you have machines that you can never change and that you can never deploy anything like an Upwind solution on top of, you do scan that once a day. But again, you lose the kind of visibility into the real-time traffic and the ability to build this very granular baseline. You also, as I have mentioned, have these identities, right? And these are either user identities, human identities, or machine identities, also called non-human identities. And you want to map the whole dependency graph, the whole authorization graph. So what that means is you go all the way back to your identity provider. Maybe it's Okta, right? That's where you start out. But then you have all of the roles and permission sets and groups inside IAM. So at Upwind, we marry all that information together. But again, that's the sort of shift left concept. You can determine a lot from that. Like, do I have a high privilege identity and maybe I should shrink down the surface area that this identity can access? But then you also marry that with how is this identity, this role, normally used in my production environment? If it's normally used, even a high privilege identity can be okay. If someone assumes a high privilege role and they've never done this before, that's a big no-no, right? That's something that kind of the runtime can diagnose. But then again, you tie it back to that shift left concept. You tie it back to when was this created? Was this done by a user, like we just added the high privilege? Or is this being done kind of on the server maliciously? So you need to map all of that back. And again, that marries the shift left and shift right together. The next thing, of course, seems very straightforward, but it's the ability to look at all of my resources and how are they connected to the internet. And everything you see here was not mapped by someone creating a network diagram. I don't even know what people create network diagrams in anymore. It used to be Visio. But the reason I don't know that is because nobody creates these because they're worthless, because it changes all the time. And so we don't do that. We actually look at your resources. We determine what is taking inbound internet traffic, what is communicating out to the internet, whether that's one cloud, multi-cloud. Maybe you're communicating with another cloud. Maybe you're communicating with a managed service or a software as a service provider, right, in addition to us. And again, we use that with the baseline, with the identities, with the resources that you normally access to determine what's normal and what's going to be anomalous. Even this by itself, we get told by customers, is valuable. Sometimes people have no idea that there's some resources exposed to the internet, or no idea that some resources are accessing their S3 buckets, or have access to some database that processes PII or PCI or PHI, right, sensitive data. So just being able to discover this and have a complete inventory, which we can build in as little as 24 hours, sometimes it takes a day, right, once you deploy us, that will help you pinpoint what are my most critical business risks, how do I shrink the surface area for attacks, and how do I do this persistently without work for my developers, without work for my DevOps team. Right? You don't want them to have to kind of keep this up to date. This is just automatically kept up to date. And the last thing, which I think is actually kind of fun, given that the founders of Upwind come from a previous startup that was a cloud optimization company called Spot.io, is that by monitoring your network in real time, you can actually spot things like wasteful network spending. Remember that map that I just showed you? You can actually discover that you have resources communicating with each other across availability zones, across AZs. And if you don't need that, right, if it's not for redundancy or resiliency, That's just wasteful spending. So we had a customer who saved between 25 and 40%, not because we built a cost optimization feature, but by shifting right, by monitoring their production environment, and then marrying it with the shift left, like what is it actually supposed to be doing, they were able to highlight that there was something going on in their environment that they didn't need to actually run their production applications. So speaking of customers, right, I actually think this is the biggest measure of whether or not a vendor or a cloud provider is telling you the truth, which is what are their customers willing to say about them. So all of the statistics that I have quoted, 95% reduction in noise, 10x faster to root cause, be running up, in 5 minutes or an hour, have a baseline in a day, those all came to us from customers. And these are customers in kind of different places. We have people from the developer side, the DevOps side, the SecOps side. We have people in every industry. And I think that's true, right? This is a cybersecurity conference. It's not an industry-specific conference. What I started out this presentation with is the argument that cybersecurity is the most important thing in technology today to solve. And I know this will give some people pain, but I think it's even more important than AI. I think about this, right? Consumers, businesses. What is not important about security? Like, do you want your health data leaked? Do you want your personal data leaked? Do you want your social media posts to be out there? Do you like replacing your credit card because hackers got on it and then sold it on the dark web? Do you want nation states to be able to attack critical infrastructure inside whatever country it is? I don't want any of these things to happen, but they happen every day. And the reason is not because people aren't putting effort into solving them, but I think most people are putting the effort the wrong way, right? They're kind of buying individual point solutions, or they're looking for single magic bullets, right? I'm going to shift left. I hear this from CISOs sometime. We're going to buy a code scanning tool and then never introduce a vulnerability into production. I have never, in the 25 years of working and running large development teams, ever seen that be successful. I suppose it's possible in the future, but they say that's what the definition of insanity is, right? Doing the same thing over and over again and expecting different results. I've also seen nobody solve the problem purely by shifting right? We've had firewalls for a very long time, right? Hardware firewalls, now software firewalls. We've had the notion of ACLs, right? Access control. We have the notion of RBAC, role-based access control. All of these are important tools in the arsenal, but nobody has actually solved the problem. Look, at Upwind, I think our solution is great, but it doesn't literally solve every problem in the environment for you. What I think we do, and I will spend the next 10 minutes or so showing it to you, is make it much more efficient for you to do so. As I said earlier, none of you really want to use a cloud security platform. You want to be secure, know if you're secure, know if you are getting more secure or less secure over time. That's really what you want to do. You want to do it cost effectively. You want to do it efficiently. And so whether or not you kind of come see us at the booth later and start a proof of concept with Upwind, or you do something else, like you just take the first half of my presentation and try and put it into practice at whatever company you work for, that's what you should be focused on. It's the outcomes for your business, right? It's avoiding breaches, avoiding downtime. It's making your developers, your operations, your security engineers more efficient, more effective, more confident. Those are the outcomes you should be focused on. So, because live demos are always dangerous, I recorded this. If you would like a live demo of this, like I mean live, I mean as in somebody from the Upwind team at our booth will actually walk you through this, and you can kind of direct us any way you like to go. You can come see us at the booth in the expo hall. Giant surfboard, big palm trees, can't miss it, right by the keynote. All right, so this is our platform here. What you're seeing is the map. I talked about this earlier, right? And in this map, everything you see here that I'm clicking through was discovered by our sensor or our cloud scanners. So that means everything, all the resources, the network flows, was auto-discovered for you. And as you can see from this timeline at the bottom, we keep track of that over time so you can know what the changes are, right? That's actually important in security. When you actually look at an individual resource, all of this information comes from our runtime sensor, right? So we can know, again, what's a normal amount of traffic, what's normal for it to communicate with, right? You can see these network insights here, and you can see how fast this platform is. This will be your experience in production as well. So this information alone could be really valuable for you, right? If you don't have a comprehensive inventory of what's going on. You can see my inbound throughput died here for some reason, right? You can see these are the connections that I've observed. This is kind of what's normal. So this is what forms our baseline. But right here in all of the tabs that are inside of our inventory capability, we have all of this information which you can kind of go through. You can look at the map, you can look at individual resources, you can look at the compute nodes, your storage, all those things, right? These are API endpoints, and I'll show you a little bit more about this later. And then this is like a baseline that's being built here, right? You can even tag things on your own inside the Upwind platform, even if it's not tagged inside your infrastructure. You could tell us this is a machine that processes PHI or PCI. And then we will use that to either raise or lower the severity of threats and risks later. And here's the timeline, right? Is I can just adjust it and say, like, well, what did it look like 2 days ago? What did it look like 3 days ago? So maybe you're investigating some kind of complex attack where something happens, and you want to kind of go look at it and be like, when were the vulnerabilities introduced, right? Was there any build or deployment? This environment doesn't change much. Maybe your environment changes a lot more. I mentioned vulnerabilities in our vulnerability funnel earlier. This is really like the magic. So we had 835 vulnerabilities that we found that any source code analysis tool would find. Only 831 of them are in use. Only 64 of those vulnerabilities are deployed on a resource that is taking any active internet traffic. Further, only 23 of those are even exploitable. 14, there's a fix available, and only 9 have a high CVSS score if you combine all that together. So this information, this dashboard, gives your CISO or your VP of software development some idea of the exposure you have in your environment and which things are a higher or lower priority. And you can see kind of over time, this environment hasn't changed very much. Maybe your developers are getting worse or better in their code practices. But when you filter it down to those 9, I don't even tell them, hey, there's just 9 CVEs. I tell them, here's the CVE, here's where it's deployed, here's the image it's on, here's the package, right? Again, maybe all that resource information is useful to you so you can know why it's important to go fix this. In this case, it's in LangChain, which is an open source LLM development application or package. And then inside the image that I'll show you here, this is like, I can go back all the way to the pull request. So I can tell you what resource it's deployed on. You don't have to go hunting for this. And this is automatically integrated with your ticketing system, with your Jira, your ServiceNow, with Slack, with email, like whatever it is you use. So now I can find out that I can fire this developer because he introduced a vulnerability. Maybe you don't fire developers. We do, just directly, straight to fired. More seriously, right, you can actually literally look at like who over time is kind of doing those things. We do the same thing with threat detections, right? So threat detections are kind of the opposite, the inverse. This is people attacking you from the outside versus you making yourself vulnerable. And so here you're going to look at the triggering event, right? What happened that caused us to take an event, which is the millions of things that are happening in your cloud environment, to turn it into a detection that you need to go look at. And I can see the process information. I can see whether this was related to a code change. In this case, it actually wasn't, right? Like somebody deployed to this service a year ago, very slow-moving environment. In other cases, you might have introduced a vulnerability that then got exploited via a threat, like a detection that kind of came in from the outside. And instead of making you hunt down what is it that I need to do to fix this, we give you the remediation steps right here. So now your security engineer can take care of the problem in real time, right? They can isolate the pod from the network, dump the contents of the logs to disk, etc. We can even let you replay SSH sessions. Maybe you're following best practices and you don't allow SSH on your machines, but if you do, some of these will be normal, but you might have abnormal SSH sessions. And so you can replay exactly all the commands because we have runtime packet process level information. API security is very similar. I mentioned this a couple of times. We automatically discover everything in your API catalog and build it for you. Again, that alone is better than a lot of sort of API-only solutions. We look at the normal amount of traffic, the normal amount of errors, the normal types of information that this API processes. Right? So maybe it does process PII. But if we detect that it's suddenly processing what looks like social security numbers or passwords, That's probably somebody trying to exfiltrate that data from your system with some kind of weakness. So we run hundreds of tests to do that. Then when it comes to identities, remember how I talked about we gather all this information from your identity provider. We show you this whole graph here that takes you all the way from like the identity provider to the IAM, to the roles, the permissions, the resources it has access to. Even this inventory can tell you a ton of things, like maybe you didn't even know there were hundreds of identities. Maybe some of these haven't been used in months. Maybe you can go clean those up, right? Maybe it has broadly permissive policies that you didn't intend this role to have. I don't actually see a ton of people in my experience going through their identities one by one. But you see this non-human identities thing up here? If you're using Kubernetes or any kind of container system, you will have an explosion of non-human identities, right? And this tells you, like, what do they have access to, right? All the way from, the controller all the way to the permission set. We use this information to kind of highlight identity-based risks in a screen called Issues that I'll show you. But you could just scroll through all of this, and you could go back to your DevOps people or your developers and say, what is going on here? Like, we're not managing this effectively at all. So we definitely see that with the larger companies or people who are like brand new to Kubernetes. Posture, this is a very sort of traditional area for security tools to take on. If you're using AWS, you're probably familiar with the AWS CIS framework. And this is a set of best practices across these areas here that if you're following them and you get a 100% score, the idea is that you're pretty secure. Obviously, this environment on purpose, this is a demo environment, is not fully secure. And so we give you the ability to understand where you are and kind of aren't meeting the bar. I don't personally actually think this is that useful. I think people over-rely on CIS. So what I really like is when you marry that posture information or the identity information or the threats and the vulnerabilities into what we call issues. This is the combination of all of those things. Right here, I have a secret that has been accidentally leaked, but it's also on a machine with a critical vulnerability. So that means if somebody gets access to it in that machine, they can do other things kind of from the machine. Or if I filter it down to kind of issues that are based on threats, I can have a threat, in this case, somebody like executing a suspicious process on a machine that is also publicly exposed and also has a critical vulnerability. That combination, that toxic combination, makes it much more dangerous for this to be exposed. So people who are customers of Upwind, they use this Issues tab as a to-do list. Now, this environment is intentionally filled with threats and so forth. But we had a large customer who found 54 issues when they deployed us across 15,000 nodes. Now they have 1 to 2, maybe a week, right? Because they used this to get the DevSec and Ops teams together in ways they otherwise wouldn't be. It's very difficult to know if something just being publicly exposed is problematic. But if you know that public exposure plus vulnerabilities plus threats are happening, you get everybody together in one room. This is kind of the to-do list. You should really have almost no issues. You're always going to have some vulnerabilities, some CIS issues, that sort of thing. In this case, I actually am responding in real time to a threat. And so we give you the ability to kill the process in real time while you kind of go figure out whether you got to roll backwards, roll forwards. We can restart that termination protection, for 6 hours, 12 hours, that sort of thing. This is, again, one of those conveniences where you want a tool that doesn't make you say, okay, I have this information, now I've got to go somewhere else. I've got to spend a bunch of time figuring out how I kind of deal with this problem in the interim. Seconds count, minutes count. So speaking of seconds and minutes, this is my favorite new feature from us. This is called Stories. Sometimes you have a bunch of threats or issues that are actually correlated, but it's very difficult because they happen across minutes or hours to understand how they fit together. So we pull all of that information, again, using those baselines and the anomaly detection, and because we're looking at your runtime, and we can tell you, like, this is a coordinated security breach. What you have is somebody who's found an API vulnerability. They have exploited that to find another vulnerability or a leaked key or an exposure or a high privilege identity. And now they're fanning out. They're attacking you in multiple places in multiple ways. And now you don't have to gather this information. You know everything that's happening that's related to the same security breach, security issue, and you can kind of deal with it all at once. This saves people. This is that 10 times faster to root cause. Instead of getting everybody on a call and trying to get everybody to correlate it and creating a shared Google Doc or Quip or whatever it is, you have that already done for you. So, I was really excited by this feature. We hear it saves customers a lot of times. Speaking of saving time, the last thing I wanted to show everybody is what we call workflow. I talked about this. Jira, ServiceNow, email, Slack. We give you the ability to determine how you want your people to be notified. Do you want a ticket? Do you want an email? Do you want a Slack message? Do you want this to, you want to use our a webhook, because you have an SNS topic or something else, or a queue, right, that kind of peels things off from your security platform. We support all of that in a highly configurable way. We don't take destructive actions on your behalf. In my experience, it's really nice to believe that a security tool can do all of that for you, but the level of trust you have to say, I want you to maybe take down my production application, even in kind of a targeted way, is so high that I have never once actually seen that work out for people. Usually what happens, and especially with VM-based applications, is you'll have something that detects a breach, shuts down a whole port 80, port 443. The whole production application goes down. Didn't need to, but it does. And then all of the alerts fire for the DevOps people. Everybody's freaking out. Nobody knows what happened. And in fact, whoever set up those rules, they're not even on this call, right, because it was automated. So what we do is we take all the context together, right, that runtime context, the build time context. We provide it by whatever mechanism you want, and then we give you the instructions so that you're all together. Your DevSec and Ops people are all together, and you can make a decision like, I'm going to kill just this process, or I'm going to contain this pod so it has no inbound, outbound network traffic. And then I'm going to spend the 30 minutes, the hour, maybe it even takes 6 hours going, all right, I'm going to roll back. I'm going to roll forward. I'm going to change this identity because I've now figured out that it isn't needed at this privilege level across anywhere else. Those things do take time. We don't have enough context about your business, and I don't think anybody does, for you to trust them with that kind of like destroy your production environment. But at the same time, that doesn't mean you need to give up on having something that makes your life easier. So with all of that kind of out of the way, I wanted to thank you for coming here today. I really appreciate your time. I know you had to kind of come out of your day to get here, and maybe some of you flew from really far away. And thank you very much. I've got a few minutes I can kind of pop over here and answer questions.